Hey guys, in this video we're going to be covering activity 6B.3. Our mastery learning objective is I can prove triangles are similar by applying the side angle side similarity theorem. So far we talked about angle similarity. When two triangles have two angles that are congruent. We talked about side where all three sides are proportional to each other. And now this is just another way to prove that triangles are similar, is side angle side. So just in its name, it tells you exactly what you need to prove in order to say triangles are similar. So literally side angle side. We can use this when triangles are similar. Oop, there's no I. If two sides, notice we see a side and a side, are proportional, because that's the way we prove if they are congruent. We have to set up those ratios. And the set of angles between them are congruent. So once you find the two sides, you have to find the angle between them. So the angle in between, the angle that basically is like the vertex of those two sides. And in case you ever forget that, look at the way that we are talking about this way to prove triangles are similar, right? Side, angle is in the middle. So the way that we are going to look at this is, let's go ahead and look at these triangles over here on the right side. I see that each of them have two sides labeled, and I also see that angle A and angle P are a perpendicular angle, meaning 90 degrees. So what I'm going to go ahead and label first is I'm just going to try to see if my sides are proportional. So I'm going to go ahead and find my small side here, which would be 6. And I'm going to put that over my small side over here, which is also 6. 6 over 6 simplifies to 1. All right, so that's one side. I'm going to go ahead and look at my other side, and I'm going to say my big side, which is 10, and put that over the big side over here, which is 8. 10 over 8 actually simplifies to 5/4, which is not equal to 1. All right? Looking at the angle between them, we do have this angle right here. This means a 90-degree angle. This means a 90-degree angle. So angle P is congruent to angle A, but the fact that our proportions of our sides are not equal, these two triangles are not similar. So all the sides and the angle in between has to be proportional, and the angles in between have to be equal. So let's look at a couple examples here. Looking at example number 2. So I'm going to go ahead and look at some proportions of my sides. So I'm going to look at this side right here. I'm looking at that small side, which is 2. And I'm going to put that over my small side over here, which would be 4. 2 over 4 simplifies to 1/2. Then I'm going to look over here at my other side, which is 3. And I'm going to put that over my other side over here, which is 6. 3 over 6 is also 1/2. Those are equal. So far, they are proportional. And then we look at my angle. Well, I do see that angle B, is 60, and I see angle Q is 60, but that's not the angle that's in between both of the angles. The angle that's in between that we need to look at is angle A. And the angle that's in between both those sides is angle P. And we don't know what those are. So these in fact are not congruent. They're not similar. So therefore these triangles are not similar because I don't know what angle A or angle P is, and I don't have another angle to figure out what those missing angles are. Remember, all three angles inside of a triangle add up to 180. So you at least need two of the angles. So that one's not similar. Let's go ahead and look at example number 3. So looking at example number 3, I'm going to go ahead and find, do my small side of this triangle. So that's going to be 4 over the small side of the other little triangle, which is 2. 4 over 2 simplifies to 2. Looking at my other side, which would be 6 over the big side over here, which is 3. And 6 over 3 also equals 2. So our sides are proportional. That's good. And then we have to look for the angle in between. Well, the angle that's in between both of those sides would be this angle as well as that angle. So that is a congruent angle. Those are also vertical angles. So the way I'm going to write my angle would be angle MPN. So MPN is congruent to angle. The fact that I did the blue first, I'm going to have to do the blue line first. So QPR. QPR. All right, so sides are proportional. I have my angle in between those two sides. Therefore, my similarity, I don't know what I was trying to say there, similarity statement is going to read triangle MPN is similar to triangle QPR. Notice we used a little similarity symbol. It's not the same as congruent. Congruent has that equal sign underneath. All right, let's look at example number 4 and 5. So finding my small side. So my small side here, I'm going to look at this triangle. So that's going to be 20. And I'm going to put that over my small side of my other triangle, which should be 24. Go ahead and simplify that in your calculator. 20 over 24 simplifies to 5/6. If I look at my big side now, 25 over 30. That simplifies to 5/6. That's equal. So our sides are proportional. Now I need to see if there is the angle in between those two sides. So the vertex of where that blue and red line meet is this angle at P, which is 37. And then this vertex is angle D, which is also 37. So that will work. Angle P is congruent to angle D. Right? They are both 37 degrees. So now I'm going to write my similarity statement. Triangle, I'm going to go RPQ. So RPQ is similar to triangle FDE. So again, if you notice the way that I wrote it, I did blue line to my vertex, down my red line. So then I have to go blue line to my vertex, and then my red line. So yes, the order does matter in your similarity statement. So please be careful when you are stating what the order of the letters in your triangle. All right, our last one here. Looking at my small side. 3 over my small side here, which is 4. 3 over 4 does not simplify. So that is going to be my most simplified answer for my short side. And then I'm going to go to my big side, which is 5. Over my big side here, which is 6. But 5/6 does also not equal. So those are not even proportional. So you really can stop right there because the sides are not proportional. Yes, we see that this perpendicular line means that these two angles are congruent. So if you want to write that for yourself, just because you know that they are equal to 90 degrees, but the fact that our sides are not proportional, we can't say that these triangles are similar. So this is simply just not similar because we do have that angle that's in the middle, but our sides are not proportional to one another. All right. Our next example is just another proof. Again, deciding how we're going to prove that triangle X, Y, Z and ABC are right triangles, so that's given. They tell you some information here that X, Y, and AB are proportional to Y, Z, and BC. Is that enough to prove that these triangles are similar? So again, the way that we set our proofs up, you always have the statements on one side and the reasons on the other side. Whoa. It's supposed to say reasons. So the first thing you always start off is your given information. So the fact that they told us that we have our angle Y and angle B are right angles, because it tells you right here that this is a right triangle, right? So I'm just going to say my first statement is that angle Y is congruent to angle B because of the fact that, well, right angles are congruent. And why are they congruent? Well, because right angles are always 90 degrees, right? Just to kind of keep that in mind. So that's angle Y and angle B. Next thing is they tell us that I have this similarity statement, or this equal, comparing some of my sides. So let's look at what this says. So this is XY and AB. So XY would be this side right here. That is going to be equal to AB. All right. Then this is equal to YZ over BC. So again, I'm only looking at this statement right here. So YZ would be this side and BC would be this side. And the reason for that statement, well, that was what's given to us. So is this enough now to say that triangle YXZ is similar to BAC? Well, yeah. We have the two sides are proportional to each other. That was our statement number 2. And then we have the angle in between them that is congruent, right? Angle Y and angle B are congruent. So therefore, that is enough to say that triangle YXZ is similar to triangle BAC, and the reason for that is, well, side, angle, side, similarity. So again, if you want to abbreviate side, angle, side to the SAS, you are more than welcome to, but I just want to make sure that you know what that stands for. All right, that brings us to the end of this video. You can go ahead and work on that activity. Good luck.